Now let's talk about some of the forces we're going to use in our word problems. So the first one that is in every problem, unless you're in outer space far from any planets, is gravity. So the force of gravity is really a mutual force between any two objects that have mass. But in this first part of physics, we're going to focus on the attraction of objects to Earth or Mars or the moon or something like that. So when we do that, this force is always down toward the center of the planet, even when the object is not in free fall. If it's not in free fall, that means something else is keeping it from falling, right? Which we'll talk about in a minute. So that force, the magnitude of it, you can solve for by just multiplying its mass times our favorite number, 9.8, and then put a negative sign in front, assuming you're choosing down as negative. We'll get into like the details of like adding and subtracting forces when we do problems, but you can see that I've chosen to put the negative sign in the formula, but you don't always see that because books are kind of counting on you to remember to use signs appropriately when you solve problems. Your book does something kind of funny with this. So it talks about weight as being an upward force. I don't see it like that. So I would say do what almost every other textbook does, and it uses weight as a synonym for force of gravity. You'll see some AP problems where W, capital W, is the force, and it's a downward force instead of FG. That is okay to do. Okay. Well then, what is keeping something from falling? If you're talking about you standing on the floor, it's the floor. If it's your book sitting on a desk, it's the surface of the desk. So we call that force that's holding something up the normal force. But it's not always an upward force. It depends. If the surface is like at an angle like that ramp there, then the normal force is always perpendicular to the surface. We can even talk about the normal force coming from a wall if you are something is pushing up against the wall, and then it's definitely not an upward force anymore. It's an outward force. So in this case, normal is used in the sense that it is, I think, in your math class, where normal means perpendicular. Okay. Then when we talk about normal force, sometimes it does cancel with gravity and it has the same magnitude as gravity. But sometimes it doesn't. And so when you look at your scale, for instance, if you have a bathroom scale at home, what that scale is showing is really not your weight. It is the normal force that it is putting on you. So when we solve these problems related to apparent weight, that's kind of a typical problem where it asks you what is the scale going to show in an elevator that's accelerating in a certain direction. So that's a strange situation, but it's testing and asking you to solve for the normal force, actually, and not your weight. So just a heads up on those. Okay, then we have friction, and we will get into this more in Unit 4. But you're going to run into it already in this unit. So for now, we'll just talk about it as a general force that resists motion, and it will act opposite to the direction of motion or possible direction of motion. If somebody's trying to move something, it might not even be moving yet, but the reason it's not moving is because there is some friction between this object and the surface it's resting on. Okay, then we have tension, which is a term that's reserved for a force that's in a rope or a string or like a chain. So this is a term that's used because those types of things can never push. They only are capable of pulling. And the rule here is that if the rope is massless, like whatever, it's got a really small mass, then the tension is the same at every point along that rope. And basically, it's just a means of transferring force so that you can get the force from your hand to pull on this box, right? So it's more convenient for you to pull this box, let's say, than to go push it from the other side. So its job is just to transfer the force for you. Then I want you to know, because sometimes the pulley thing is confusing, but really the job of the pulley is just to change the direction of the force. That's all it does, okay? It just takes a force that was in this diagram, pulling to the right, and allows you to pull down on the rope rather than pulling to the right on the rope. Big whoop. But it is important that to make sure that we're talking about a massless, frictionless pulley, and then we'll worry about pulleys that have mass later in a different chapter. Okay. And then what if you don't know? You just have some unknown force that happens sometimes. So then if you're asked to label a diagram and you don't know what's causing a certain effect, then you are just allowed to call it applied force. That's what I would do. Okay. All right.